Um, Hello guys, my name is Kakembo Owen. I'll be taking you through artificial intelligence using my project called Mood Tracker. So we all know a relative or a close friend who is suffering from a mental health issue that is maybe stress, anxiety, depression, PTSD, and so many others. So picture an app or an AI that reads your facial expressions, moods through the tone while it's interacting with you, and then sends you motivational messages or messages of encouragement, connects you to therapists or doctors. So among the types of data, of course, the AI is going to need images, sound, and text, right? But then we shall look at some of the disadvantages of or the problems that AI may face, the technical problems. But anyway, so I'm going to take you also through supervised and unsupervised learning in AI. There's also reinforcement learning, but that's not for this video. So in supervised and unsupervised learning, picture, or most all of us have been through schools, okay, most of us, and we think of the teacher-student narrative, right? So we have a teacher and then the student who's going to be assumed as the AI. So when the teacher is teaching, the AI may give input and maps it certain type of output. For example, if they say 2 plus 2 is equal to 4, that's he's giving it input and then the expected output. That's mapping input to output. That's in supervised learning. While in unsupervised learning, when the teacher walks out of the class and maybe leaves an assignment, that would be the input, and it's the job of the AI to find out or decide what is going to be its output. So there are other differences. There's so many differences between supervised and unsupervised learning. If we are to put it in the sense of the teacher student, in the supervised learning, we're training the AI using labeled data. In unsupervised, we are training the data using unlabeled. So we are training the AI using unlabeled data. Then in supervised, there are categories like classification and regression problems. In unsupervised is clustering and association. In supervised, there is feedback. It takes direct feedback while predicting correct output or not. Check if it's correct output or not. While in unsupervised, there is no feedback, as you all know in the teacher-student scenario. There's the others, but I'll skip those and go straight to the techniques in supervised learning. So in supervised learning, there are two techniques. There is linear regression and classification. In linear regression, here the AI finds the relationships between the quantitative data and then predicts and forecasts the output. So it forecasts or predicts a certain output for a certain input. Then in classification, it's going to predict qualitative response by analyzing the data, and then it recognizes the patterns. So whenever I give it input and the more input and output you give it, it will keep recognizing those patterns and then try to apply them to the next set of input that you give it. Then there are also techniques of unsupervised learning where we have clustering and association. In clustering, here the AI groups data based on the similarities and differences. For example, if you use oranges and grapes, the AI will, can group them in terms of shape, color, size, diameter, and many other features. Then in association, here the AI gets the relationships between variables in a large data set. So there, as I said earlier, there are challenges in the types of data data that we input, not actually challenges in the types of data we input, but then some some of the technical challenges come from the data we input. For example, data privacy, the images and the text and sound, it can be really worrying to an individual because first of all, I do not know if it is safe to give this AI my information. What if it leaks it and all those other thoughts we can have? Then there's data quality issues. How good is the output of the AI? Then there's data corruption, that the AI is susceptible to falling victim to corrupted data because the algorithm it uses feed the data, assuming the data it's given is completely correct. So there are also possible solutions. Now, under the solutions, we can isolate the sensitive data and ensure it's only accessible to a particular part of the AI or the system. Then we can also improve its accuracy and quality through giving it more data, adding it more data, or yes, majorly adding it data. Then we can also crowdsource, collecting more data, web scrap. Then we can also improve the quality through ensuring that the data is relevant, comprehensive, up to date. So now, so if we're to continue with the example of happy and sad faces, precision and recall are used together. So precision, if we're to split the data set into happy and sad faces, in that the happy faces has an exception of having some sad faces, and the sad faces has an exception of having some happy faces. So if we're to only take the happy faces, sorry, so if we're to take the side of only sad faces, um, the AI picks out that these are the sad faces. We shall get those number of sad faces divided by everything on the side of sad faces. Then recall, if we're still going on with the sad face side, we're going to get the number of sad faces on that side divided by all the sad faces in the whole data set. Then F1 score is it's used to express the performance of the machine learning model. So this marks the end of this video. If you want their references to this video, references to the data that has been collected in these slides. Thank you.